Hello, my name is Chad Husko, and I'm the founder and CEO of Iris Light Technologies. And our company is going to change the way that you think about light. Now, you may have heard that the phone in your pocket is more powerful than the computer that got us to the moon. You might be asking immediately, well, how is this possible? Or you might have even know that fact already. The answer is chips, the electronics living inside of the phones. Right? And we know chips are everywhere. They're not just in phones. They power the computers, they power cameras, even our microwaves, smart appliances, everything. Now, what if I also told you that we're in the middle of a brand new chip revolution where instead of just electricity, we're now using light? This is silicon photonics or light chips. And light can do a lot of things that electronics can't do. So you can really think about this silicon photonics industry as the marriage between optical technologies, which are a $500 billion industry, with electronics manufacturing, which is also $500 billion a year. Right, living right at that intersection, we have our light chips that are giving unprecedented performance, and we're talking a whole bunch of different areas that optics traditionally plays a role and new ones that it's unlocking. We'll go into these in a little bit. I want to make this a little bit more tangible for you and talk about a place where light chips are already having a huge impact. Now, optics has been in the data center for quite some time now. And you might have heard that data centers are in fact what drive the cloud. And Cisco just had a report that said 95% of all data center traffic is driven by cloud applications. And of course, it's only growing. This is a crazy area of growth. Now, where are light chips exactly? They are the things that connect the different servers inside of the data center. So for example, when one computer wants to talk to another one way on the other side, it does not go through electricity, but rather it goes through a light chip in order to make that happen. Quite simply, electrical signals don't work. Now, with this insane growth rate that we're talking about, we're already witnessing huge performance boosts every year in terms of energy efficiency, cost, and performance for light chips. This is also a huge environmental problem because data centers are consuming between 2 and 3% of global electricity and also that amount of global emissions per year. Further, there's a bottleneck inside of the data center. Current demands project 1,000x required bandwidth increase in the next decade. This is because of the Internet of Things, edge computing, and of course the AI cloud, which isn't even here yet, which will even be a bigger bandwidth hog. So we need to solve this problem. And this is exactly where Iris comes in. With our method, we can put hundreds of lasers directly on the chip to give a higher degree of integration. And if there's one big lesson we learned from electronics, it's that more integration leads to that bigger performance. And with more lasers here, we're able to overcome and crack this bandwidth bottleneck in chips. Now compare that quickly to what's going on there today. The limit is 4 lasers, and the roadmap looks pretty sparse beyond going beyond 4 lasers. And we have a truly unique solution to solve this problem. Iris is the way forward to get the super dense integration required for this ecosystem. Now, this is only the beginning of the story. That's only value proposition number 1, putting lasers on the chip. Here's a second critical one that is truly differentiated for Iris. And this is the availability of a wide color spectrum. While others are focusing their solutions on a single market, single application, Iris has a color spectrum that will enable continuous growth over decades to come. Now, this happens through 2 key methods. One is the tunable ink color. So our inks can be tuned, just like a printer has different colored inks. Iris has different colored inks. Most importantly, from a business perspective, what this allows us to do is rapidly prototype and meet the demands of our customers who demand different colors for the different applications that we showed you with these icons here. For example, in the world of gas sensing, so explosive gases in mining or methane detection, instead of 4 different sensors required for covering one application, you can make one Iris chip with 4 of those sensors embedded directly on the chip. In this cloud example that we're giving you, right, you can get way more bandwidth for the same cost. And equally important, you can have more energy efficiency in terms of bandwidth per chip. There are endless possibilities with this technology on one single platform. And the best part is what we've just shown you there is just the tip of the iceberg. We're enabling a whole new Moore's law for light chips. All those different applications, that's just the beginning. And now is a perfect time to invest in this technology. Light chips are booming. The market has gone from commercial launch in 2010 to $1 billion this year. And it's only accelerating in growth. We're talking about 45% growth projected over the next decade, crossing $23 billion by 2030. Now, to solve this problem, we put together a strong team. Shown here are the current Iris teammates. Myself, founder and CEO, I have a PhD from Columbia University. I've worked in silicon photonics for over 15 years, managed a number of programs around there. L.A. Price, who joins us in business development, and Josh Wood, who is a co-inventor and a nanomaterials expert, including manufacturing. We're also joined by industry expert Michael Lear, Leon Tsutsumi, and Rick Penning, both of whom have worked in industrial startups here in Chicago. And that's just our core team. We also have an extended network of individuals who have joined us who are experts in photonic inks, printed electronics, nanomaterial synthesis, and so on. In the past 2 years, we've gone from an Argonne National Lab spinout. The first big investor in this technology was the Chain Reaction Innovations Program. We are currently based at Argonne, where we're doing this work, combining photonics and materials, which is perfectly suited for Argonne. We have acquired a partner in AIM Photonics, who has provided us with in-kind support through chips. We've also landed non-dilutive funding from the Department of Idaho. And here you can see Sam and Florent here, 2 of our other teammates working full-time on this program, synthesizing the inks and the nanomaterials. And also recently, we secured a phase 2 contract from the Air Force to go along with our investment from the Clean Energy Trust and a more recent angel investment. Now is exactly the time to accelerate. We're building on a foundation of $1.3 million of funding already secured, and we are raising. Right now is the perfect time to get up on that S-curve and to accelerate the Moore's law for light chips right here with us in Iris Light Technologies. The future is light. Iris Light.